This is home learning and the subject is computer science. The topic we're going to be looking at today is defensive design, and to get you a little bit of content, a bit of knowledge at the start, we're going to hand over to Mr. Holton, and then there's going to be a number of tasks for you to do during the course of this hour to 2 hour session. So over to Mr. Holton.
So let's have a look at some principles of this thing called defensive design. And this is the idea that people who use your programs might fall into one of two camps, and that are people who are deliberately trying to damage or hack into your program, and they could fall into the camp of people using your program in ways you're not really thought of or not expected. And we're going to cover how to try and protect against a few of these things. And the first thing we're going to have a look at is this idea of authentication, and this is quite simply making sure that you've got usernames and passwords set up for people, so they can't log into the website or can't use your program, rather, if they are not allowed to. So let's give you an example of that. Very simply, we're going to be using the worst website a lot today. We've got a username here, let's say it's in Hulton, and then my password is 1234, which is a terrible password, but it's the one I've chosen, and I can log in with that. That's fine. But if I type in my username and a different password and hit login, it doesn't let me. It says unauthorized, we are hack proof, which is a bold claim indeed. But let's have a look what happens if I do this. I'm going to type in my username and I'm going to put a special character in. You see that there, that apostrophe? That is really important. And then I'm going to put this curious command in afterwards, this 1 = 1, and hit login. It's let me in, even though that's not my password. And the reason why is because I've used this thing called an SQL injection attack, and I haven't sanitized my input. So there's a principle for defensive design called input sanitization, which is where we remove every single special character in there which should not be there. And what I mean by special characters are things like apostrophes or a double = sign or double negatives. They've got no reason to be in a username or a password a lot of the time. Right, let's see what happens if I try to create an account. My program here has to have usernames in letters only, which is fine. That's a lot of websites can have that. But what happens if I've typed in a username and tried to create an account which has got letters and numbers in? Oh dear, I've broken the website, and that's because I haven't validated my input. So I've got this idea of input sanitization, but I also need to make sure I validate all my input as well. And this is just purely checking that data is in the correct format, the format that you expect it to be in. You know, if you ask somebody for their age, you probably assume that a lot of people type in the number, but you can be sure somebody's going to type in their age as a word, and that can crash your program. If I turn on validation, so I'm going to put on here where I validate my username, and I try to create a new account with numbers in it, then it shouldn't let me anymore. There you go, validation, username must include letters only. That's validation. That's an important part of defensive design. Another part is this idea of verification. If I try to create a new account, let's just call it NWHO like that, and then I type in the password, but perhaps I fudge it a little bit. I type something wrong when I'm doing it, and my password's not what I expect it to be, and I hit create login. It doesn't let me create my user account because my passwords don't match. So that's verification there. It's checking to see that users have entered what they thought they had. The last piece of defensive design, which we're not going to cover in this video, but you need to be aware of, is this idea of making maintainable code. So creating maintainable code. So that's all about comments, about using indentation, about using sensible variable names, all that, and we'll cover that in another video. And they're your principles of defensive design.
So for the first task, you need to sort out some examples of validation and show how they could be used and what they're called. You've got 10 minutes for the task. Off you go. Okay, time up. Time to review your answers. We'll go over to Mr. Barnes to do this.
Okay, so let's have a look at this validation task and match the types of validation to description example. I've just reshuffled mine to make it a little bit easier for the purpose of this walkthrough and answer check. So starting with a presence check. Well, a presence check makes sure that something has been entered. So we can say checks that data has been entered into a field. An example of that is making sure that data is entered into a particular field. So for example, if you were signing up to a website and you needed to enter your first name, you could add a presence check to make sure that something is entered. The next one then will be check digit. So check digit is where the last 1 or 2 digits in a code are used to check the other digits are correct. So it does like a mathematical calculation to make sure that the data hasn't been corrupted or tampered with. An example of that is, let's have a little look, a barcode reader in supermarkets. So the number below a barcode in a supermarket uses a check digit, and that makes it checks to make sure that the previous digits before it are correct, so it is the right item being scanned. Okay, next up is a length check. Sort of does what it says on the tin, this one. Checks that the data isn't too short or too long. Okay, so for example, a telephone number is a really good example. It has to be 11 digits long in the UK. But another example is a password which needs to be 6 letters long. Next up, we've got a lookup check or a lookup table. So this checks a set of known values in a table and gives those options. So postcode is a really good example. You can type in a postcode and it will give all the addresses within that area by looking up that postcode. But you can also do a lookup which normally comes in the form of like a drop down box. For example, days of the week, as there's only 7 days in a week. Next one up is format check. Format checks sort of does what it says on the tin again, checks data's in the right format. So for example, a phone number, it must be 11 numbers. But another example is national insurance number, so it has to be in the form letter, letter, number, 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 letter. And then that leaves range check. So range check checks values fall within a specific range. And a good example of that is a number of hours worked must be less than 50 and more than 100. So there are all our answers. Hopefully you've reshuffled them to get them in the right order.
For your next task, you need to look at some input sanitization code and provide some code comments to show that you understand what that code is doing. This will be great because it also tests some of your 2.2 programming skills as well at the same time. So use where the hashtag is as the start of your code comment and show that you understand the code beneath it by providing an appropriate comment there. And we're going to go over to Mr. Barnes, who's going to review your answers.
Okay, so for this task, you were given some Python code and you're asked to explain how it sanitizes the input. Okay, so where there's a hash, you needed to add a comment like you would normally do in Python to explain what that line of code does. So input sanitization is really good for preventing SQL injection because it removes characters that you wouldn't want entered that could potentially damage or bypass security mechanisms. So let's have a look at what this code actually does. Okay, so the first hash, below it we've got new word equals speech marks. So what this does is it sets a variable called new word to blank. Okay, the double speech marks means that there's nothing stored in it. Okay, so the next line then, if you're familiar with Python, word equals input, enter a word. Okay, ask the user for an input. And stores it in the variable word. Okay, so they can enter, for example, the word hello. So next up, we've got for x in range 0, len word. Well, len word returns the length of the word. So if you entered the word hello, it would return the value 5 because it's got 5 letters. It's 5 in length. For is a loop. Okay, is iteration. So what happens for everything that's indented? It will go round and round again. So this loop will repeat from 0 to the length of the word, but not inclusive of that number. So 0 up to 5. So 0, 1, 2, 3, 4, but wouldn't do it the 5th time. So I'm going to say this is a loop that will repeat for the length of the word. Okay, so next up then we've got if word x equals open bracket and then new word equals new word, elif word x equals close bracket, new word equals new word, else, and then some other code. So let's break it down. So x is our counter. So what that means is x will start at 0, and the first time through this loop, if word 0, which would be the first letter, equals a bracket, then what it does is it basically removes the bracket by not adding onto the new word variable what that letter is. Okay, so I'm going to say this checks if a character, each character I should say, is an open or close bracket. If it is, it doesn't update the new word variable. Okay, so what it means is that instead of adding that letter that's been checked onto the new word variable, it just ignores it. So if it was a bracket, it just doesn't add it on. And then we get to the else part, and what we'll do is we'll have a look at how this works in a minute. So on the else part, we've said, well, if it's not an open or a closed bracket, i.e. we're not, if it's any other letter, we're going to add the letter being checked onto the new word variable. Okay, so if it isn't a bracket, the character will be added to the new word variable. Okay, and then at the end simply it prints the new word. Okay, So what we're going to do now is we're going to have a look at actually how this would work in practice. So I'm just going to replace this sheet with a blank one. So let's imagine my input was going to be hello, but with one of the L's it's an open bracket. So in my word variable I've got HE open bracket LO. So for X in range, 0 to the length of the word, so the length of the word is 5. Okay, so first time through, X is going to be 0. Okay, so if word 0, so the first character is an open bracket, well, it's an H, so we go on to the elif. If word 0 is a closed bracket, well, it's an H, so we go on to the else part. Okay, so at this point, new word has nothing in it. So we're going to do the else part, so we're going to say new word equals what it currently is, which is blank, plus word 0, which is the H. So new word becomes H. At that point, X is going to increase by 1. So then we go back around the loop. And this time we're saying if word X, which is 1, which is the E, is an open bracket. Well, it's not, so we go to the elif. It's not a closed bracket, so we go to the else again. And then we say new word equals new word plus word 1, which is the E. So new word was H. I'm going to add on to it an E. And then X is going to increase. And then we go back around again. So if word 2, which is the R open bracket, equals an open bracket, which it is, so we're going to do this bit here. So new word equals new word, so it stays the same. We don't need to check the elif and we don't need to do the else because the first condition was met. So we go back round again. X now becomes 3. So if word 3, which is the L, is an open bracket, which it's not, so we go to the next bit. It's not a closed bracket either, so we do the else. So we've got new word equals new word, which is HE plus the L. So we've got HEL. X then increases to 4. So we go around again. If word 4, which is the O, 0, 1, 2, 3, 4, is an open bracket, it's not, so we move on. It's not a closed bracket either, so we do the else part, and we say new word equals new word, which is HEL, plus word X, and X is 4, so that means it's the O. And then it increases to 5, and we break out of that loop. So what's happened here is when it prints new word at the end, it's going to print HELO. All it's done is sanitized or removed the open bracket. Hopefully that walkthrough makes sense.
As always, we're going over to exam questions. You've now got 10 minutes to complete the questions, and Mr. Barnes will review these afterwards. Make sure when we're reviewing these questions that you're making notes or adjusting your answers accordingly. Over to Mr. Barnes.
Okay, so you've now had a go at answering these exam questions about defensive design. So let's go through mock-ups and model answers and then look at the mark scheme. Okay, so the first thing says, describe 2 examples of defensive design when developing a program. Okay, now, key thing here is, this question is worth 4 marks. Okay, so you're going to get 2 marks just for identifying 2 appropriate defensive design techniques. So straight away, I'm just going to write input sanitization. And I'm going to write validation. I've immediately got 2 marks without even really doing much for the answer. Now, to get the other 2 marks, you're going to need to explain how these work. Okay, so I'm going to explain input sanitization is when unwanted characters for example I'm going to say a percentage are removed from an input. Okay, then for validation I'm going to say this is when checks are made to ensure the data input follows a set of rules. Okay, so let's just move that up slightly and then let's have a look at what the mark scheme says. So there's a number of different answers. I've gone for input sanitization and validation because that's what the previous 2 activities have been about. So here I've got 1 mark straight away just for writing input sanitization. And then I've got a second mark for saying it removes unwanted data or unwanted characters. And it says also by example, so I've definitely covered that mark off for a second mark. Perfect. For a third mark, I've said validation, and then I've said this is when checks are made to ensure the data input follows a set of rules. So here, checking whether the data follows criteria. Perfect. Okay, full marks, so that would be 4 marks. Now let's have a look at the next questions. So there's quite a lot of information here. Mrs. Smith runs a dog sitting service that looks after dogs whose owners are away on holiday. She uses a database for 2 tables. The table dog stores the following data: ID, name, sex, weight, data arrival and data departure. The job table stores daily jobs that need to do with each dog. So the dog table contains fields for sex and weight of the dog. Describe a validation check that can be done on the sex field. So out of all those different possible opportunities, I would say with a sex field it could be male/female, it could be M/F. That can make it quite difficult to apply a number of the different checks because male and female are not the same length. They're not. You can't really apply a format to it. So I would say for this one, if they need that information, they need to have, oh, and I've wrote it in purple, a presence check. Alright. And this makes sure that something is entered, e.g. male/female. Okay, next one then, describe a different validation check that can be done on the weight field. So we can't use presence check again here. So with a weight of a dog, it's gonna be between a couple of boundaries. Okay, those boundaries might be quite large. A tiny little Chihuahua is not going to weigh much, and then a massive Great Dane is going to weigh quite a lot. But I think it's perfectly possible to set a range check here. Okay, and to say that this needs to be between 2 weight values. Okay, so let's have a look at the mark scheme here. I'm just going to put that above. So the mark scheme is not overly helpful. It's e.g., so it gives interpretation. So existence check is the same thing as a presence check, so that's going to give us 1 mark. Okay, now male, female or similar allowed. So I've said this makes sure something's entered and explained what a presence check is, and I said e.g. male or female. Okay, then for the second validation check I've said range check, perfect, and I've said it needs to be between 2 weight values, so that's explaining how it can be done. 2 marks for this one, 2 marks for this one, perfect.
And that's everything from defensive design. Stay tuned for the next lesson.